So we're going to do a few more. Don't worry about the notation that they're using. We haven't used before. I've made mention of it, but they're using these sort of to say the complement of. They're using those horizontal lines. They're actually useful for when you're saying the complement of some joint event. But I'll stick with the complement sign. And so for E, what we're being asked to do is to figure out probability of the complement of event A. And remember, the event A is the offender has 10 or more years of education, right? And so I've also put together a Venn diagram here, which shows a sort of a visual depiction of the entire sample space, the entire exhaustive set omega, which is the rectangle, and we've got a blue rectangle for representing the event A. The red sort of trapezoid is representing the event B. And I haven't used, I don't want to mess things up, but so B complement, I've used some orangey yellow, but I'm not making I'm not doing the geometry, the trapezoid of it. So it's easier for me to get a sort of approximately the percentage, just so you can think of the area of these guys as corresponding to the appropriate percentages. But it may be easier for you to think in terms of if a Venn diagram is helpful at all to you, to be just thinking of sort of the traditional one where you have a couple of circles like like this, A and B, to sort of think about their intersection as being the overlap and the union being all of them together. But in that case, it's harder to make the the areas kind of work out to being sort of approximate to the ones that are in the table. So the probability of the complement of A, well, we know that the probability of A we saw already was it's the probability of that first row. So the total, regardless of convicted or not convicted, is 40% or 0.40. And so the probability of a complement, we know, we have our, I think it was the first theorem, theorem 1, that tells us you could take 1 minus the probability of the event itself, and we would get 60% or 0.60. And right, we can, with the table itself, we can really read directly off of, so the 9 years or less is the complement to the 10 years or more, so we didn't even really have to do that subtraction because we had it right there in the table. But I'm going through these steps because often you won't have the table. You might have just gotten the information, right? You might have just been given the fact that the probability of event A is 0.40, and you're asked to get the probability of its complement. That is to say, the probability that that event is not true, that it's not 10 years, that someone in this program did not have 10 years or more of education. And so you want to be able to make use of these axioms and theorems that are rather straightforward. Okay, so the next one, F, is the probability of, I'm going to write it in the kind of the notation we've been using, which is the probability of the complement of the union between A and B. So the overlap, not the overlap, the union, or A or B. What's the probability that it is not the case that A or B occur, right? So that is, if you want to think of it as I'm randomly sampling someone from the treatment program, what's the probability I happen to pick someone who neither had the higher level of education nor was convicted within 2 years of treatment? And let's think about that in terms of the table, where are the which is the cell of the table, which is the entry that corresponds to that, the event of neither of those things happening, right? So, right, if you think about it in terms of the, if you think about it in terms of the upper Venn diagram, that's just kind of what you're usually used to. It's if the union is everything inside those two circles, then the complement is anything that lies outside of those two circles. And in the sort of a little bit more appropriately sized one at the bottom, right? We're looking at where's that spot where that's the complement of the union of A and B. Well, here is B is all this stuff in here, and A is everything in here. And so the complement of the union of those two, right, that A, right, the union of A and B, that is to say A or B, one or the other or both happening, right, where does the complement of it? It's everything that's not in either of those places. And in fact, I I tried to make that rectangle kind of follow the pattern of the table itself, and so it's that 0.33 is what we should get. But again, I'm gonna use the rules and see if it matches, if we get the same calculation. So we know that this should be the probability of the complement of A union B is 1 minus the probability of A union B, using that theorem 1 again. We calculated the probability of A union B last time, and that is if any one of the three of these cells is captured. So if anyone who has 10 years or more education, or is convicted within 2 years, or is both of them, anyone who falls in that. So 1 minus that 0.67 that we got at the end of last video, and indeed that's 0.33. Okay, so next we're gonna do G, which is the probability of the complement of A intersect B, right? So the probability that it's not the case that the events A and B both occur, right? Okay, so in the notation that we've been using, probability of A, so that's a parenthesis, not a C, probability of A intersect B, take the complement, right? So it is not the case that both A and B happen. What's the probability that we are not in that overlap? And so, in the upper simple Venn diagram, right, there's the intersection. So anything that's not in that intersection would be the complement of the intersection AB. And so in the one below, where's the intersection of A and B? It's the part with the blue and red, right, which is corresponding to that 0.10, right? That's those who are convicted within 2 years and had 10 or more years of education. So we want 1 minus that probability, 1 minus the probability of A and B both occurring. 1 minus 0.10 equals 0.90 or 90%, right? And here we can see that that complement of the intersection means you're lying somewhere in here or here or here, right? Which is to say somewhere in the 0.27, 0.33, 0.30. Notice we can add those together because it's keeping us from. Notice, like, we learned about the fact that we can't, just add. We can't add 0.60 to 0.63. We'd have to subtract out the 0.33 because we don't want to double count it. But in this case, when we're working from a table, we're not in danger of double counting because we can just take the individual 0.27, 0.33, 0.30 and add them together, or we can take 1 minus the thing that we're saying is not going to happen, right?